Hey everybody. In class, we got a lot of practice working on word problems that involved multiplication and division. Tonight, we are going to see a bunch of different kinds of word problems, sort of do a little bit of review about how to tackle all the different kinds of word problems that we're going to encounter that involve one-step equations. In our first example here, we have Usain Bolt. In the 2015 World Track and Field Championships held in Beijing, Usain Bolt won gold medals in both the 100 and 200 meter dashes. He ran the 100 meter dash in 9.79 seconds and the 200 meter dash in 19.55 seconds. Write and solve two equations to find his speed in each race. So, like we saw on our last set of notes, the distance equation that we can use d equals rate times time, this can help us find the distance, the speed, or the time. Any one of those three things that we're looking for. In this first situation, well, both of these we're looking for the speed, right? And in this first situation, we know the distance, 100 meters, and we know the time, 9.79 seconds. So I can set up an equation that says 100 meters equals the speed, that's r, we don't know that, times the time, 9.79. So I'm going to write 9.79 first, and then the speed. Now, to solve this equation, right, this is multiplication going on here, so we're going to divide by 9.79. Divide by 9.79. And we get r equals, now I got a long decimal here when I did this in the calculator. Since this is a real life situation, we can round it. I'm going to round it to 10.21. So we want to think about what does this number mean in terms of the actual answer, right? We're talking about speed. We divided meters by seconds. So our answer is 10.21 meters per second. So that's the speed for his 100 meter dash. Now the 200 meter dash, we're going to need a separate equation. We know that 200 meters, right? 200 meters, he ran in 19.55 seconds. So that's 19.55 r. Now we're going to solve this one the same way. We're going to divide by 19.55, divide by 19.55, and we get r equals 10.23. Now once again, we divided meters by seconds, so our speed, the units for our speed is going to be meters per second, 10.23 meters per second. And we notice he actually ran faster in the 200 meter dash than he did in the 100 meter dash. Let's take a look at our second example. On weekends, you volunteered to drive a van to transport patients to and from a senior citizen's home. The van you use has a wheelchair lift that has a maximum lifting capacity of 300 pounds. The average wheelchair weighs 55 pounds. We want to write and solve an equation to find the maximum weight of a person who uses the lift. So let's underline what we're looking for. We want to find the maximum weight of a person who uses the lift. Now, I can use W here to represent that. Weight of person. It's the weight of a person who uses the wheelchair lift. Now I want to put a box around the information I need. 300 pounds, that's the maximum capacity, and a wheelchair weighs 500 pounds. That means that the wheelchair plus the weight of the person at its absolute maximum can be 300 pounds. So here's my equation. 55 plus W equals 300. Now to solve this, this is addition here, and this is a positive 55. So I'm going to subtract 55 from both sides. 55 minus 55 is 0. 0 plus W is W. W equals 300 minus 55 is 250. So the answer to this question, the maximum weight of a person who uses a lift, is 245 pounds. And that abbreviation is LBS, stands for pounds. All right, we have cooking in this example. You made a small batch of cookies by using only 1/3 of the amount of each ingredient used in your mom's best cookie recipe. If you used 3/4 of a cup of butter, how much butter was used in the original recipe? As always, we're going to underline what we're looking for. How much butter was used in the original recipe? We can use B to represent that. We'll say butter, and to make sure specific, I'll say in original. Butter in the original recipe. Now, I know that we used 1/3 of the original recipe, and we used 3/4 of a cup of butter overall. So the final amount we used was 3/4 of a cup, and we used 1/3 of the butter in the original recipe. 1/3 of a number, that means multiplication. 1/3 times B. So 1/3 times the original amount equals 3/4. Now to solve this, since this is 1/3 times B, I'm going to multiply by the reciprocal. 3/1 times 3/1. 3/1 times 1/3 is 1. That leaves us with 1b equals 9/4. 3 times 3 is 9. 4 times 1 is 4. So 9/4 of a cup of butter. Now, when we're dealing with a real-world situation with an improper fraction, sometimes it makes more sense if we write this as a mixed number. 9/4, I know 4 can go into 9 twice, and there will be 1/4 left over. A mixed number is better, especially when we're talking about cooking. So 2 1/4 cups of butter. So you can say 2 1/4 cups of butter. It's a lot of butter. It's probably why those cookies are so good. All right, in our last example, you paid for a new jacket that cost $65.25 using a debit card. The balance of your checking account is now $172.35. Write and solve an equation to determine what your account balance was before you bought your jacket. So we want to determine what your account balance was before you bought the jacket. We can use A for that. Account balance and this was before. So if A is the account balance before, I know that the jacket cost $65.25, and this is how much we have in our checking account now. So that $172.35, that's the final amount, $172.35. That's what it ended up at. Now I know if I had $80 in my bank account and I spent money on a jacket, I'd be taking money out of my bank account. I'm going to need to subtract in this equation. Minus 65.25. If we draw a line through our equal sign, we can see A minus 65.25. I can add 65.25 to both sides. Because we have subtraction up here, we want to use the inverse operation, which is addition. Negative 65.25 plus 65.25, that gives us 0. We're left with A equals, going to have to add this up, and there we go. $237.60 is what we originally had in the bank account. $237.60. That's our final amount. And that is our final example.